Okay, here we are with functions 2, example 2. Right here we have a function from n cross n over to n. Remember, n cross n is the set of all ordered pairs where the first coordinate is a natural number and the second coordinate is a natural number. All right, like I said for the previous video, what you got to do is fill in the table, and then you'll be able to read off the data from the table and answer the other questions. All right, so first let's fill in the table. Okay, so our rule is f of mn equals m times n. So f of 1, 1 is 1 times 1, or 1. F of 1, 2 is 1 times 2, or 2. F of 4, 5 is 4 times 5, which is 20. Okay. Uh, 10, 2 is 10 times 2, which is 20. Okay, now we go the opposite direction. Now we're given, now we're given the output, which is 0. And we say, what are two positive integers or 0 that multiply to give you 0? And you guessed it, 0, 0 works. What's another one that would work? Yeah, that's right, 3, 0. Or choose anything really, right? Choose anything right here, that'll work. Or if you put a 0 there and anyway. Okay, so 3 works there. Lots and lots of possible answers here. That's the point that I'm trying to make here, is that you can do lots of possible answers. Infinitely many for that one there. Okay. Okay, we got a 2 there. What are two things that multiply to give you 2? Now, look, we've already seen this before up in this part right here. Now, remember, like I said in the previous video, the only way you can use these tables to fill out the rest of the problems, the rest of the parts B and C, is if this side here is filled out unique. So each of the entries is unique, except in the situation when you have D and E. You can have multiple D and E's, but other than that, everything should be unique. So if we want that to be unique, we don't want to have 1, 2. So we can't have 1, 2 here. What's another way to get 2? You guessed it, 2 times 1. 2, 1 there. Okay, now we ask ourselves, once we have the table filled out and we're sure about our table, make sure that everything in the left-hand column is unique, except for, of course, maybe the phrase D and E, or the abbreviation D and E. First we ask ourselves, part B is the function onto. And all you have to do with the way that I've created these problems, the way I've structured these tables, is you just look in the left-hand side, this left column here, and if you don't see any D and E's, then it's onto, and you can skip to the next thing. Now, to be ultimately 100% for sure that it is in fact onto, you would need a proof. But I'm not going to make you prove anything like that in this class. Okay, so but let's just look at what would happen. Okay, so we have n there, we have n cross n there, and we have the function f. So let's be completely general. Let's pick a number in the target. So we'll use a letter to stand for that number. And what's a letter that we haven't used yet? Yeah, K. Yeah, let's use K. Okay, so K is a natural number. And now we're being totally general, right? So we just want to find some ordered pair where both of the x and y coordinates are natural numbers. That comes over to K. So what's something that does that? Yeah, you're right, 1K does, right? 1K does. And yeah, you're right that there is other ones too. K1 would work as well. And depending on what K is, there may be more. If K is prime, then there's not going to be any more. But it doesn't matter how many there are. It's really just that all numbers in the target have something that comes over to them. And in this case, just because we don't see any D and E's over here, and if you want to think of it more intensely, you can think of it like this. The math majors will have to do that in later classes. But you can say, well, okay, it's definitely onto. No D and E's here. No D and E's over here, so we're going to skip to the next part. Okay, now, because I filled out the left-hand column entirely unique, I can decide if it is one-to-one or not. Now, remember, one-to-one, all you really have to do is ask, are there any repeated values here? And you can see that, yes, there are, right? There's repeated values. There's actually a couple, right? There's the 2's, these are repeated, and the 20's are repeated. And there's other ways to get 20, right? 5 times 4 is 20, not just 4 times 5. So another ordered pair that would, if I had more room and I wanted to, I could put a 5, 4 here, and I would get 20 as well. So that's another way that it fails one-to-oneness. Okay, but you see what's going on here, right? Is that we have 1, 2, and 2, 1, and they both go to 2. Remember, this is not one-to-one. In general, right, this is when you have a situation like this. It's not one-to-one. You can see that happening here. All right, so you just take your 2 points that you have there, 1, 1, 2, and 2, 1, and that is a counterexample. That shows that we are not one-to-one in this case.